quickly introduce the panel today. So starting from your left, Matt Bacanti. Matt is Senior Product Manager at GE Aviation. GE Aviation is one of the most rapidly growing business units at GE, and they work mainly in the civil aviation space and in the defense space, as well in autonomous systems. Also with us today, Keenan Johnson, the Head of Engineering at Impossible Aerospace. If you follow the news in recent weeks, you must have seen the US-1, which is one of the most sought-after drones made in the US, coming to the market this year with a 2-hour flight time. With us as well today from Switzerland is Lorenzo Morzilli. Lorenzo is Manager of Innovation and Advanced Technologies at the Swiss Federal Office of Civil Aviation, FOCA. And he is a very demanded key panelist. It's already the second panel at AUVSI Xponential. And he is very well known in the industry. He is the father of Sora and is spearheading the efforts in drone UTM in Europe, but as well in the rest of the world. And last but not least, Shane Hastings, Product Line Manager at AV. AV is the largest provider of drone solutions to the US DoD, with over 85% of units last year. Before joining AV, Shane worked as Director of Quality at In-Situ. So please put your head together for our panel here today. Quickly, my name, Kevin Sartori. I'm the co-founder of Auterion. Auterion is a software company. We build an operating system for drones. So it's all the software you need to fly a drone. So it's on the drone, it's on a mobile device to plan your mission, and it's in the cloud to manage your fleet. Before we start with questions to our panelists, I want to quickly give an overview of other industries and really see traction open source is having after its first release in the late 80s, early 90s. So today, most of the cloud workload is managed by open source software with Linux, which covers more than 90% of everything cloud, everything internet. A derivative of Linux is Android. Android is built on top of Linux, and it runs on billions of devices. And I think if you look at those numbers, most of you must be using an Android smartphone. It's open source is the most distributed software in the world. If you go at company adoption, that's a report from 2015. Numbers must have been growing in the last years. 4 out of 5 companies use open source software or admit to use open source software, and a staggering 2 out of 3 companies contribute back. And we'll go more in detail about the reasons why it's good or why companies contribute back code. Last year as well, big news in industry, the largest ever software company acquisition in history was IBM buying Red Hat. IBM was vehemently fighting open source in the 90s, and turned out that in 2018, they bought a company that was selling free and open software for a staggering $33 billion. And finally, if we look at the largest contributors in terms of manpower, the top company is Microsoft. And I'll just repeat that. The top company is Microsoft, with over 5,000 contributors to open source projects. Looking at the list, you see other companies that as well in the past were really fighting open source. So why is that? And here I want to turn back to our panel, and I'll start with Matt. Matt, do you want to explain what open source is?
Yeah, so from a high level, I view open source as a community of developers, whether that be organizations or individuals working collaboratively together to solve a particular problem. And what's most interesting about that is as you provide that that definition, at least from my perspective, is that sounds like it's extremely well organized, and in many cases it is. But what we've found is that the majority of the collaborations we see in the open source community is leveraging the strengths of the individual contributors and organizations and working together. And often those strengths and the solutions that the community comes up with it are unintentional, and unintentional in a positive way. We see that as just being an extremely positive and valuable aspect of bringing multiple different perspectives together to solve common problems.
Mm-hmm. And Keenan, you're a fairly young company with Impossible. You launched your first product. Why did you jump on open source?
Yeah, definitely. So if you look at what is the biggest slowdown for all major aerospace products in the last 10 years, it's software development and testing. We do all the hardware engineering in-house, and just from a capitalistic perspective, it makes sense for us to pick. We can't have. There's not open source software for all of our problems, but there are for some of them, and so we choose to use that if we can. So it lets us put products out there much faster. And you can't test hardware without software, and that really accelerates our testing workflow.
And if I may ask, you're venture-backed.
Mm-hmm.
Now you turn around to your investor and you say, well, we just downloaded the software from the internet.
Yeah, definitely. So we're a Series A company, so we've been through 2 funding rounds at this point. A lot of people, I think, would find it very difficult to justify that to investors. I think the reality is that the thing that makes you unique is sort of the business processes that you put in place. And definitely as a hardware vendor who's producing hardware, it's a lot of the magic of what you do is not in exactly the hardware that you build or the software that you write, but how you put all those things together and make a really reliable product. So, the results kind of speak for themselves about how you do that.
Yeah, and we've seen that in the press. Shane, question to you as well. You're probably one of the most recent adopters. They were in contact with open source just a few months ago. What was the trigger to do that?
Could you tell us your name?
Okay. Can you hear me? All right, so I'm the first one with a mic. Thanks everybody else for not using a mic. So Kevin, do you want to repeat the question?
Perfect. Let me go for it. Shane, you just started working with open source recently. What was the trigger, if there was any, to do so?
Yeah, so the real trigger for us to start using open source is that we were submitting a response back to the Short Range Recon Program through the United States Army and DIU. The requirement for any solicitor was to provide a really Mavlink protocol Q ground control solution with your system. For me and my experience, that was really the catalyst that got us into the open source as we were working to execute for that program.
Any feedback so far?
Well, if you don't know AeroVironment, largely we're a system provider. So if you heard of Puma, Raven, and Wasp, it was mentioned that there was a statistic that of the unmanned aircraft inventory for the US DoD, 85% of that is AeroVironment's gear. Not only is that aircraft, that's all the ground control station and the support equipment that supports the system. Largely that's, it's a system in a system, so it's proprietary digital data links, homegrown software, and the like, video processing. So when we went to this DIU solicitation, it put us on a vector that had, at least to my experience, hadn't been tried. The experience was interesting. We had a learning curve to get on. We've got software engineers back at the ranch, as I like to say, that are doing coding all the time. but largely working in the Mavling protocol isn't something that we do on a day-to-day basis. So working with that sort of command structure with our proprietary command structure was something that we had to learn and work through as we were going through that program. I think the experience, I'm not there saying it was positive or negative. I will offer an example that we did download a revision that was on GitHub that actually broke a link for something that we had tested, and then we downloaded an update, and it actually broke something in our system, so we had to unwind. And so while it's just a one data point, it is something that did give us consideration as we start looking at open source as being a contributor to a system that may or may not take all of the updates that are being provided by the user community.
Good, thanks. I think we'll talk later as well about review processes or validation processes that companies follow when using open source. So we'll come back to that point. Matt, I would love to know, GE Aviation, legacy company in the aviation space, now adopting new technologies, there must have been a thorough process you went through on the business side and on the technical side to evaluate solutions. Can you guide us through that process?
Yeah, absolutely. And I think that the most important aspect of our experience as we've worked through product development and release cycle really comes down to how do we meet our customer needs. And before I get into that, I think one important note to make about our process is the way that we've gone through the development is really oriented around the team aspect of that. We've got a team of great engineers, capability within the organization, and while I'm up here speaking about this, it's really a lot of the activity of those team members that have really helped to drive forward that vision and implementation associated with our end use. So at a high level, the organization that I work within the business is tasked with taking existing solutions and finding new business models and opportunities for growth. So as a way to kind of lay out the genesis of how our product launch came together, we used some of the existing hardware that was deployed as a part of our military programs and began investigating mechanisms by which we could actually take that and deploy that for commercial and civil use. And in that process, we first started with building our own solutions, whether that's the flight controller and many of the other ground station components. Worked our way through that process of understanding of what were all the different areas that we needed to drive forward. The second part of that is as we began to understand the complexity and the different elements that we would need to assemble in order to drive the broader solution set, caused us to take a step back and evaluate what were the different ways that we could solve this problem. And in fact, that was a lot of that information and a lot of those ideas of how we could potentially solve and offer new products and solutions originated from our engineering team and is the way that they've gone about trying to evaluate and implement that. So after evaluating different solutions, came to the open source solution, particularly as it related to PX4. And by conducting an evaluation of the different licensing models that were available, the feature sets that were available to support our end-use customers, ultimately led us down the path of selecting that and then moving forward with implementation. After the implementation, obviously, validating the performance and getting that feedback from customers has been a huge input to how we can move that forward.
Okay, so from what I understand, you went through two key decisions. I think the first decision was, do we do it in-house or do we use open source software? And the second one was, okay, now we decided to go open source software, which one do we choose? Can you guide us through the criteria for those two decisions?
Yeah, so the first level of decision-making is do we build it ourselves, or do we build it, or do we leverage open source software? I think an important distinction to make there is that there is, or we are responding to a particular large segment of the market that is asking for these feature sets. There is other segments of the market that are looking for specific needs that open source solutions may not be able to provide today. And the broader answer to how we went about doing that and selecting that really comes down to meeting specific customer needs. The second, from a process perspective, we've looked across the primary drivers of which open source solution do we bring. One being the licensing associated with that, and two being the specific feature set that is available with it as well. And so licensing specifically touch on whether it's permissive or non-permissive. Then the permissive aspect of it really is helpful, particularly from a product development and implementation perspective. And the second is the feature sets, and that's really responding to and meeting customer needs and requirements.
I quickly prepared a slide on the license aspect that Matt just mentioned. Matt, do you want to quickly discuss permissive and non-permissive?
Yeah, I think the best way to describe the differences here, I think on the right-hand side is the permissive side of things, which ultimately allows an entity to build products around open source licenses without having to explicitly contribute some of the more critical intellectual property back to the broader program. Obviously, we're interested in supporting and driving the broader community forward. On the non-permissive side is also valuable. However, the implications associated with the product launch really it drives some questions and issues associated with how specific elements of IP is controlled and managed within the product and its overarching implementation from an end-use perspective.
I keep with that because I have a follow-up question on one of the criteria. Was cost ever an issue, or like a thing you considered? So
I think from a cost perspective, certainly time to market, the ability to deliver a massive feature set was the primary driver associated with some of the open source selection process. Cost, there's a particular aspect of it. One, when I think about software development process, is the initial implementation, and two is the continuous innovation and development thereafter, or the maintenance aspect of the software release process. The biggest challenge that we see there is, or at least my view, the maintenance is the much larger cost aspect of how this ultimately moves forward, other than just the implementation.
Do you feel like that's because you went open source, or would that be true regardless?
Oh, I view that when I say the cost aspect of it is if you're trying to do it all yourself, then the statement holds true. But certainly when we think about open source, that is distributed amongst a much larger group of entities or individuals, and that inherently does reduce the burden if it's how it's specifically focused within different organizations.
Like supporting that argument, I prepared a quick overview. I went into GitHub and just look at contributions of code to the different open source projects that relate around PX4. PX4 is a flight controller that you can compare to the Linux kernel. So it's the center of a drone. But on top of that, that's the lower line, and it starts in 2011, 2012. That's when the first code was written on PX4. On top, you have all the supporting pieces of software that are communication protocol, integrations with ROS to enable computer vision and obstacle avoidance. It's ground control station. It's integrations with payload. And they just stack up on top of each other. And so that just shows the increased complexity. And I have a line that says, today, I expect that to keep growing. If we do a business analysis of this, we see this curve that is basically the same, but on top of the technologies, it adds all the workflows that enterprises need, adds UTM, for example, and we come to that aspect later, all the compliance aspects. And nevertheless, since it's an enterprise space, all the integrations between the different software components and between what the data that is created on the drone and that is analyzed inside an enterprise. And that aspect of just building that software is prohibitive already per se, even for large companies. But the fact that you need to maintain that, you need to maintain all the links to the point that Shane mentioned before, that is the aspect that drives the cost sky high. Any comments?
I think you're definitely right. I think one thing that we'll probably see in the near future is thinking about safety standards for software. It is probably going to move towards a more statistical-based approach, it seems to me. And so, the number of users that there are in the software increases your statistical leverage to make safety guarantees about software. And so that's one of the reasons why I think we'll see open source software really shine in aerospace specifically. Because, I think we've seen that it's not enough to say like a line-by-line code review. We know that that is not a way to create safe software inherently. It's definitely helpful, but you always see things like hardware bugs, for instance, that can cause problems that you won't catch that way. So I think this chart basically shows the farther to the right that you go, the more statistical leverage you have to make safety guarantees against your software.
So that means you just download software from the internet and you're good to go. I would love to hear a bit more from a regulator's perspective. Lorenzo, what's your take on that?
Yeah, I'd say a healthy skepticism. No, meaning my take is this. At the end of the day, from a regulator perspective, it doesn't really matter if something is open source or not open source. I mean, what matters at the end is that you as an industry can prove that the end solution, so the machine with software integrated, the hardware, the software, the whole thing, can actually perform to the safety standards that the regulator expects, right? And the burden of proof is not on the regulator, is on the industry, right? So the point here is that from a traditional, let's say, software certification point of view, the industry had developed their standards and have proven to the satisfaction of the authority the safety of the products that are coming out of these standards. Unfortunately, the paradigm of that proof for traditional software is that because you cannot test complex software to the full extent that you would like to, you make software safe by basically wrapping the whole process of developing this software in very specific and tightly controlled ways, right? So the software safety is achieved by means of process control. And this is the opposite of that, right? So when you come into the aviation ecosystem and saying we have basically no process control because it's open source, you're basically going right at the core of what all safety experts in aviation have considered to be the central element of software safety, and you're just blowing it apart, right? And that's why, of course, from a regulator point of view and from the safety community point of view, you will find resistance. However, again, this is totally normal, right? So the burden now is on the industry, what you just said about, for example, statistical relevance and all of that. How do you actually prove that doing these things differently is actually as safe, or even if not even more safe than the way we used to do in aviation? And I think this is a conversation that really needs to, I mean, I know that it's already starting and it's going on between regulators and the open source, but it's a conversation to have, right? It's clear.
Shane, you're nodding.
Yeah, he hit it on the head. So, we sell into the international space, And our systems are required to be airworthy. So there's standards that are thrust to AV that our systems have to meet. Lorenzo hit it right, that it's a lot about the process and how you got to the end. So you have a product there, but what was your process to get to that product? And I've sat with MAA, Military Aviation Authority, and talked to them about process. We have an airworthiness team back in Simi Valley that guarantees that when you have what's called a failure modes effects criticality analysis, a FAMICA, you have statistical understanding of what your system is going to do. And when you realize when you're in an unmanned aircraft, everything that happens with that system is controlled by some sort of software. And whatever decision the operator makes is because the software is telling them the aircraft is doing something. So when you look at the process of ins and outs, it all really converges around software. The hardware is kind of just an afterthought. The software is really where it's at. We're talking not only the core that runs your computers, that runs your payloads, it's the GUI, it's all of that comes together as the overall system. And so when you're really trying to get a system certified with regulatory bodies, they want to have confidence that what they're going to get on a day-over-day basis is going to have the same level of, I guess, maturity and operation as the one that was purchased before or the year before. When you talk about change control management and configuration management, how are you locking in the configurations and how are you making sure that what you're putting in today is regression tested to the point that it won't break something, as as the example I gave earlier on a small prototype. We just downloaded the next rev from GitHub and it broke. Now that could have been our software not talking with Mavlink, whatever it was, but it forced us to do a rework. Sometimes I think if everything's closed, you have a better chance to rework things. I'm not opposed to going to open, but making sure that you understand eyes wide open on what's coming in, how you make sure that it's safe, and that it doesn't break any of the links that you already established from a previous download. I'm open again to having the discussions with the regulatory bodies, but applying it to our system is something that we'll just have to work through.
Mm-hmm. Lorenzo, before you mentioned legacy certification processes, a bit of what Shane was saying. Many would argue that our industry is too small to absorb the cost to do that, and that really be prohibitive for the compositing industry. You also mentioned open source approach, just getting the best out of different companies can potentially lead to a much better final product. Mm-hmm. So what is your recommendation to the industry, to all of us here, to move forward and somehow bridge the gap between the legacy certification and the new approach or a new approach?
Yeah, that's a tough one to answer. I think the key here is that regulators are by nature, they don't trust anything. They assume nothing, they believe no one, and they don't trust, right? So you need to build trust and confidence to the regulator that your processes and your procedures are actually good enough, for them. Now, the challenge here is the same, and I think we were discussing with you before. I heard you saying, I don't want open source to become a buzzword. So if we start discussing, do we like open source or not? Do you believe it's nice or not? What do you think about it, right? This is definitely not going to bring you anywhere. I think what you need to do is start to put data and analysis and numbers and processes on the table and start to discuss about what is a good open source. What we were discussing before coming in is like, what does open source tell me? How many contributors do you have? What is a community that I can consider trustworthy? How many contributors do you actually have? Because if I am an industry and for example, I am failing to push my standard, into the ecosystem, a good way to do that is to open source it, right? And to try and make this a de facto standard just because it's open source, right? But do I have a community around this open source software that is supporting the development? Or is just myself? How many contributors, how many users do you have? So all of these parameters might eventually end up into a standard that the regulator can use to judge, the appropriateness of use of certain products. You mentioned PX4, you have all these statistics. Maybe that's good enough, right? Maybe you can say the community that is out there, the amount of users, the amount of contributions, the variety of contributors, and makes this product, trustworthy to start to work with. But maybe there are other products that are also open source that are completely rubbish. So the point here is not what is open source or not, is how do you qualify the quality of that effort, and how do you inject that by means of a standard into the processes that we are discussing about today. And again, this is not something that you can expect the regulator to do. They will not do it. We will not do it. Number one, there's no time, there is no competence. This is something that you guys have to do. And then go to the regulator and start to interact, you know, and build this confidence.
Thanks, Lorenzo. Keenan, I see you often on Slack and on GitHub. How how would you define the community or differentiate a good versus a less good community? And also, when is a community helpful?
Yeah, I think a good open source community is one that has, I think, first a good body of knowledge about how the software works and maybe like common issues that you might encounter first. The second is they have an active, group of people who kind of understand the software and are paying attention to all these process controls that we were just talking about. Like, so the open source community, a good healthy one, has a set of processes that they also follow, just like a company. So I think those are the first two things that I primarily look for. I think the third would be, just on sort of design and testing of the software. Have the people who wrote the software, do they have some sort of plan, and do they have some sort of testing, even if it's not super deep on the integration level? I think those are kind of the three things that I would look for an open source community.
Mm-hmm. Matt, question to you, changing a bit gears, but starting again with the same question. You download software from the internet. How do you make sure that it's enterprise ready, that your organization can stand behind it?
So I think the best way to look at that particular problem, and it's something we've certainly wrestled with, is first and foremost the rate of change which we're observing in the industry today. The way that features, functions, new capability is being integrated, whether that be from an open source perspective or even on a closed source perspective. I think we all would agree that change is happening just really rapidly. To address some of the conversations Lorenzo was making regarding some of the more traditional software validation process, for those familiar, would be the traditional DO 178 activities. And the biggest challenge I see there is that that change and the amount of time that it takes to get through that ultimately means many of those features and functions may have already been superseded by new and different at the time. So inherently, there's a pressure to figure out how can we take advantage of that change, deliver expectations for our customers, and there's the way to express or to qualify the enterprise readiness, I'd say, is one, is there an enterprise solution provider similar to what we've seen in the Linux operating system side of things with Red Hat or Canonical? The second is looking at the community. I think Shane and others have had experience with that. Specifically, Keenan is a part of the conversation and being actively engaged in that. The number of users, how many people are actually involved in the activity. And finally, recognizing that there is a need to formally validate and verify these different components. One way to particularly address enterprise needs while still meeting expectations from a regulatory perspective is to accept and build into the product the ability to implement change while still formally verifying components of the solution. So that concept isn't new. It's runtime assurance, and that is a mechanism by which you can leverage open source software but still control the specific performance of the hardware on different unique either failure conditions or fail-safe conditions.
You asked me before what I was recommending. I mean, these two answers, for example, I mean, they already indicate a possible way, right? You have like specific 3 points that I want this, I want that, and I want that. If I have these 3 signs, I think this community is healthy. So why don't you guys start to write down this and say, okay, when, for open source software to be used in drones, this is what we want to see, right? And build up from there, processes like the one you described, and really start to work towards a standard that uses completely different paradigm from the one we use today, but still maybe gets to the same result. But this is the conversation you need to have.
Good, thanks. Shane, you started almost from zero. You had millions of lines of code in front of you. How does one get through that? How do you get up to speed?
I don't know.
And I will ask the same question to Keenan afterwards, because you went through the exact same shocking effect.
So clarification, I did not, and I was not looking at 1 million lines of code, just for clarification. So yes, when we were going through a prototype effort back in December and January, we had to reach out to folks that understood the code that could enable us. We spoke with Auterion for guidance. We were implementing a PX4, and we wanted to understand a little bit better how to make that work with some of our GNC for this vehicle that we were working on, and then integrating it into a payload video chain. And so I think for us, it was trying to find the right subject matter expert that could enable our software team to start speaking together on a common language on doing, again, a system solution. It wasn't a bit solution. We were actually providing an overall system which needed this software to be really at the core. And so from us as being a longtime system provider, reaching out is not uncommon for us to find subject matter experts if there's something that we're just not well-versed in, and we did. And so we got smart for a portion of it. I would say probably a couple hundred lines of code, maybe 1,000 lines, but certainly not the million. And I think, it was a positive experience to go through that. Even though we had that one little hiccup, it didn't, give major cause for concern. But I thought for us to get what we needed to do in a relatively quick timeline, we were successful. If we were to do, and I think it was successful because of the people that we worked with, and it was successful because I think largely the code that we needed was already there from the community. And when we talked about it back in California, one of the things that we wanted to make sure that we understood, as Lorenzo was talking about, is that wrapping this around a process, a secure process, knowing that what we've got going in on a day-to-day basis for whatever system that we're providing is managed and controlled in a fashion, and that we control the updates, vice the user community controlling the updates. And so, at any rate, that's how we got up on the learning curve for that initial, and we're still on the learning curve.
Yeah, I think my answer is probably very similar to Shane's. Like all these processes we're talking about, Matt talked about there's two parts of sort of the software development. There's the initial implementation, and then there's the validation phase. If you're a company that's shipping products to end users, you ultimately have to own that process control on the backside. So, the first kind of step that we did after we figured out, okay, we kind of have this feature sets that we need. This software seems like, at least at the surface level, it can do that. What are the processes that we put in place to check if it's doing that sort of on a repeatable way? And then, once we kind of had that, obviously you run into little issues or things you maybe don't understand. There's some awesome folks out in the PX4 community that really helped us a lot in the very beginning when we were, kind of in just the R&D phase, just kind of poking around and seeing what was going on. Those people, I think some of them are employed by different companies, some of them just do it for free, and they really helped us quite a lot. And I think, there's a couple different open source platforms that exist, and you'll figure out pretty quickly which ones are healthy based on who you can talk to, who will give you answers to your problems. So probably very similar to Shane's answer.
Keenan, staying with you, you mentioned several software packages or components, some of which you're using open source, some of which you might develop in-house. How do you merge that? How do you control of your IP as a company? And I would love to ask the same question to Matt afterwards.
Yeah, I think that's a really good question, and that's one that we face all the time from investors, since we've sort of been through the venture stage part. They want to know that our business will not be copied by some Chinese company who will do it for 10 times less than we can. And I think there's a couple parts. One is, the really valuable part of a business is just a series of processes, and it's like, how do you repeatably produce good products, and how do you make sure that your products that you have stay working? And those are both process controls, and setting up an organization that has the mindset to think in that way is quite difficult, and I think very difficult to replicate from the outside, because it's not obvious how to do that. The other part, I think, is, we build, we like to call them flying batteries. So we use the batteries as structural components of the airplane. That's ultra challenging, and obviously there's no open source software that we can download that does that. So that's something that we had to develop. So we've kind of got, this battery power system software over here, and then, like the flight control software that we run, which is open source over here. So the question is, how do you keep your IP from creeping into sort of the open source space? Because obviously you don't want that to be copied. The answer is kind of the same. You do that in the same way that you guarantee that the software is functioning. You want to create really tight interfaces between those softwares, because that's your way that you test the software, is through that really tight interface. If you were to say, we're going to compile all of the software into one binary that we just load onto the vehicle, it's impossible to say what the test interfaces are between those two pieces of software. So we want to be able to independently test our battery software and our flight control software. And the information they have to ultimately exchange is fairly little, and also not secret. In terms of things like the flight controller might want to only see like, how much flight time do I have left? Like that number is not a secret. How we calculate that number is a secret. So that's kind of my answer to that.
So I think that at least the perspective that I have on it is it comes down to the following, which is one implication of open source and or open standards is it sets a de facto expectation with customers. So to a certain extent, there's a known entity of capability, feature sets, functions that exist. If you provide something less than that, customers are aware of the different competitive solutions and the options in there. So I think inherently, in all cases, you have to meet at least that minimum standard of capability. From how do you differentiate then really becomes the question. And from a differentiation perspective, it comes down to several different components. One, I think what Keenan was describing was the specific hardware integration that you're applying. And the second aspect of that is what are the unique other value-added software capabilities that you can layer on top of the existing open source platform. And one of the things from a broader PX4 ecosystem perspective is the readily available mechanisms by which you can add proprietary value and solutions on top of that broader ecosystem. And I think that's really the key from a product and differentiation perspective. One is specific hardware configurations that really drive value or enable specific outcomes. And two, adding software and functions that really in many cases aren't core to the existing open source solutions. That is where you can drive that value and differentiation from a software perspective.
Mm-hmm. Thanks. Shane, I come back to you, which you went through the process recently. What would you recommend companies that want to try using open source software, putting into products? What would you recommend them to learn and have a steep learning curve?
So that's a good question, and I don't know if I can give a good answer, but I think the recommendation would be if you're not smart with what it is, reach out to folks who are, and at least understand what it is. I think there may be a, it's different, and so if you're used to doing your own software, germane to the systems that you provide, or the hardware you provide, or the spares that you provide, whatever it is. If you're going to adopt open source, try to get smart with what it is, try to find subject matter experts, and really understand what the risks and the rewards are. I think for us, we saw both. We saw a good reward because we were fast, because it already existed, and then we saw a risk that turned into an issue when we did have a small hiccup with it. And so it's being able to understand really what that value is that's going to provide the company, and then figuring out your path there. And if that's, for us, it was, again, trying to reach out to the subject matter experts to help us understand a little bit more about it. And then trying to find out internally, folks could get up to speed on using it, and then just like applying it. If you apply it globally to everything that you do, maybe that's too big. Maybe you isolate a key portion of your system if you're doing a system solution and start focusing it there. Like for us, we did. We isolated down to a very small portion, which was just GNC code, and that enable us to get up there a little bit quicker again, and then using Auterion in this case to help us. So that would be my initial recommendation.
Mm-hmm. Good. Just looking at the watch, we have 10 more minutes, and I would use this time to open the questions to the audience. I think there is a microphone there. Feel free to use it, and please state your name and company and who you want to ask a question to. I will put up the.
I'm Irfan Usman. I'm from Virgin Hyperloop One. This is a general question to the panel. So you've talked about maybe two paradigms. One is going through the old traditional software certification process, and the other one is kind of using a statistical approach to analyze the open source kind of ecosystem. Is there a hybrid approach where you can take certain elements of the traditional process and have the community adapt them? And then if so, what elements are readily adaptable and what are going to be more problematic?
Yeah, I don't know if I can answer in full. I think in part, I think the challenge of the hybrid, I think maybe it is a solution, but every time I put any of my safety experts in front of anything that is non-traditional, they only ask two questions. How do you do requirements management, and how do you do configuration control? Anything else is almost a detail to them. Of course you have to do it, but how do you do requirements management, how do you do configuration control? When they speak about requirement management, they don't speak about software requirements management, because this you can do. They speak about the traceability of requirements from the top level of the aircraft all the way down to the code. So if I'm saying the aircraft needs to retract the landing gear, right, I need to be able to trace that requirement all the way down to the code that does it. And obviously when I download from the internet a piece of software, this link doesn't exist, because this software is not built to do these requirements. So they really struggle with this notion, right, requirements management. And the number two is, of course, configuration control, not from a community point of view, because, of course, there you have it, but from a company point of view, that the example that he was describing before, we made an update, we introduced this software, we broke the system, right? Something went wrong in the configuration control of the overall thing. This is what they want to see, right? So I think in any hybrid solution, if you find ways to answer those questions or to find equivalents or better processes that don't need those two elements, and you're convincing, I think that's something you can start moving. The challenge that I see is that many times in these conversations, the aviation software people come in and say, what are those two things? And the answer is, we don't have them, right? And this is whoa, forget about it. I go away, right? These guys just walk away from the room, they don't want to listen. So you really need to engage on this because that's what they do. This is their bread and butter, So I guess that's a starting point, at least for the discussion.
Another approach from a hybrid model is to isolate specific components of the device from a software perspective that are critical. In one way, you could say define a safety controller that's overseeing the operations and the control of the vehicle at its highest level, and look for exceptions and take actions based on those exceptions. And similar to what Lorenzo was describing there, Once you bound that problem statement into a much smaller component rather than trying to formally verify the entire system, you can go through and formally verify that specific safety controller that would allow you then to leverage the flexibility and specifically trace the functionality using the landing gear. If we said the safety controller is observing, if the landing gear is not down when I'm close to the ground, then I take a separate action, would allow us to then meet some more of that traditional way without having to do a full verification of the entire open source code base.
Thanks. Any other questions?
This question's kind of in the same vein, and I'm not a software guy, so apologize. One of the challenges I see in the DO-178 style is that it takes a long time, and it's kind of saying, hey, I'm not going to let anything get through, but eventually when we get it in the field, things do get through. So the time to iterate that back out is very long. So we lose safety on two routes, I think. One is because iteration cycles are so long, sometimes 2 years, we have bugs in the field for a long time, and we leave, as I think the open source is basically saying, a lot of capability on the field because that iteration cycle is so long. So how do we solve that so that, this is back to the hybrid solutions, how do we generate a system that has the control and the traceability but allows the iteration, because that's also part of the safety case?
Maybe if I can build on what you just said, if I may here, I think the solution like a wrapper, it's something that many companies are considering, because clearly the lengthy processes that deal with DO-178 are not long because of the D178, but because of the software complexity that you're trying to change, like you have a flight control system of a major airliner. I mean, there are millions lines of code that you have to go through the whole process. So that's what I'm also excited about this open source, is that you could say, well, if I take all the, let's say, the brains out of that DO-178 and I make it completely open source, fully dynamic and whatever, and then I wrap it around like with a mini firewall of functions on something that is very simple, very controllable, DO-178 certified and whatever, it's a good way to start. Of course, then you have this hybrid all the time, and you have to deal with this, and maybe not all the time the wrapper is the right, maybe the wrapper is failing and the open source is right? But it's definitely a way to go. It's definitely a way to go. The other thing is that I don't think this tension between performance and safety is peculiar to software. This is something that exists in general in everything we do. Like if you are oriented to performance, you want to do faster, you want to do better. That's your objective, right? However, in a heavily regulated industry like aviation or nuclear power plants or whatever, this is not all you need to do. So it's not enough for you to come to me and say, but I need to be faster, I need to be better. I will come back to you and tell you, you need to be safe. And so, the challenge is, if you cannot prove it to me, I will not allow you to fly. The burden of proof is always on the industry. It's not on the regulator.
The point is that iteration has a safety case, and so not performance case, but a safety case. And if we don't have iteration cycles, then we are actually leaving safety on the table. So that's the point.
Yeah, sure, but in manned aviation, this is addressed. So if you have a bug on the software and you think it's a safety case, before you change it, you ain't gonna fly. So the point is always the same. This is all managed. It's a completely managed process, and that's what you need to replace.
We have stuff that we put on our panels saying in-op or something like this because we have a bug for 2 years to iterate it back out.
Yes.
So I mean, it's not,
Yes.
DO-178 doesn't necessarily address it elegantly.
No, I completely agree, but it doesn't mean that it makes it unsafe. Because the fact that you are allowed to have that sticker has been thoroughly addressed by means of plenty of safety assessments. I was doing those assessments, I tell you, and it allows you to have that sticker for a month, 2 months, 1 year, one flight, so the whole process is there. and now you're saying we want to change this entire thing with something else, which is awesome, but you still have the burden of proof that what you're putting out there is at least as safe as what exists. And that's the challenge you have, you industry have. We, as a regulator, we don't have a preference, open source, closed source, we don't care. As far as you can convince the regulator that what you're doing is okay, then we're good.
Good, we have time for one last question, really a minute.
So I think one of the most useful kind of open source elements is going to be the perception stack, basically open source training elements for neural nets, things like that. Have you guys thought about how that might actually end up being implemented, or have you guys looked into that at all?
Anyone?
I think that particular question would be a fantastic panel discussion in and of itself. Non-deterministic systems present an entirely new type of question, even beyond open source. And the ability to solve that particular question as far as how will it perform in a given number of circumstances, the two things that I'm aware of as far as how do you deal with that, one is looking at it from a statistical corner case condition. So how can we ensure that we have probed and tried every one of the corner cases that that particular non-deterministic system will see and how it will respond to that, and then can assert its performance. The second piece comes down to some of the more hybrid elements associated with what we've been talking about earlier, but certainly from the problem space that we're looking at when we start applying those types of things in safety critical operations, it creates a completely new set of problem statements that I know there's a lot of very smart people out there working on and trying to solve today.
Yeah, and I think the other thing that, there's a lot of use cases that are sort of have a very high risk tolerance for those kinds of things right now. I don't know, cats on the internet. Aerospace is not one of those applications. So at least in the short term, redundancy and sort of fault tolerance are highly critical. And so you need to make very hard guarantees about at least the safety case, maybe not the optimal performance case, especially for those kinds of systems. And I think we're going to see that hybrid approach for a while until we can, as an industry, reason about sort of those non-deterministic things more intelligently than we can today.
Cool, thank you. I think we're at the end. I took notes while you were speaking, and if I may summarize in like a minute, we've seen open source is used across the board, startup, large companies. It's saluted by the regulators. It has multiple benefits. It's a quick way to get a product up in the air, less cost, ease of integrations. It's also a way to create trust because it's auditable. However, you need to really be clear on product requirements. You need to consider licenses. You need to consider the direction of the community because you're jumping on a boat or betting on a horse and you better want that horse to win. It's seen by regulators as a way to talk and establish open standards. However, the initiative is with the industry. We need to come with proposals. We need to work together. And I really hope that this panel was useful. I want to thank our panelists. And right after, there is a reception. So I also invite you to stay for the reception. And I hope that the panelists have some time if there are any follow-up questions. But thank you very much for your attention. And put your hands together for the panel. Thanks.